calculus in college, which most of you will.
Most majors require it. This is something you need to know. Alright, so what they're going to do is give us this fraction. And we're going to break it into two separate fractions, like this example. We'll start here and we'll break it into two partial fractions. And we could check this by adding them together. Alright, so here's how we're going to set it up. As you can see for this first rational function, it breaks up into some number over the first factor and some number over the second factor. So we know what the denominator is going to be, we just have to figure out what's the top going to be. So number one, it's not factored for us, so we're going to have to factor this bottom. Yep, minus 1. So if we factor this one, we have to find factors of what? Negative 12 to add to get 1, that's going to be what?
4 and negative 3.
Very good. So when we break this rational function up, it's going to look like this. Some number over the first factor, x plus 4, plus some number, and I'll put b for that, over x minus 3. We have to figure out what a and b are. And make that an equal sign, I'm sorry. Alright, so look at all three fractions. We are going to try to find a common denominator between all the bottoms. Okay? We need what? What's the common denominator? Because we have these x's involved. The whole denominator. X plus. We have to include both of these, correct? And both of these. So the common denominator is going to be x plus 4 times x plus 3. We're including all denominators. That's the common denominator. Something that both of these, all three, can go into. So hint, hint, it's always going to be this, the common denominator. Alright, looking at this side of the equal sign, ignoring this part, if I multiply this fraction by x plus 4, x plus 3 on top, and it has it on bottom, what's going to happen? Yes, and all you'll be left with is what? Yes, just the numerator, 5x minus 1. Again, these cancel out, you'll just be left with 5x minus 1. Equals,
Wait, why did you say that cancel?
because this divided by this would be 1. They cancel. Let me put it over 1, maybe that'll help. Now you see? Okay.
Question.
Yes.
Is that supposed to be x plus 4 and x plus 3 or x minus 3? Outside of the right?
Yes, minus 3, thank you. Alright, now just looking at this term, I'm going to cover up the rest of them. If we multiply a over x plus 4 by all of this, what's the only thing that will cancel out?
X plus 4.
Yes. So we'll have a and x minus 3 over here. Let me cover them up again so you can see. The x plus 4s will cancel out. You'll have a and x minus 3 left. Yes.
Wouldn't it be... Oh, never mind.
Okay. Last term, what would cancel out? So we'll just have b times, very good, plus b times x minus 4. X plus 4, excuse me. Not yet, but we're closer. So here's a shortcut. I just showed you this part so you could see what was happening. All you have to do is, from now on, just write the top here and cross multiply here. Okay? Does everybody see that? Keep the top here, cross multiply here, and bring it down. I just showed you this to see why you can do that. Alright, now let's go ahead and distribute this a to each one, this b to each one. That'll give us what over here? Ax minus plus yes, or 4b, whichever one you write it. Alright, we're going to ignore this side for just a second. There's no like terms over here, correct? But notice two of them have an x. Alright, so let's do this. You'll see why in a second. Pull out an x out of the terms that have it, okay? Which are these two. if I take out an x out of both of them, I'll just have what?
AB.
A plus b. Very good. And then I'm going to write these terms. And there's a reason I grouped them together. Alright, if we go back up to the top, we know the top a plus b has to give us 5x minus 1 somehow, correct? So what we can do here, notice how these have an x term and these have an x term? This 5 has an x, this one has an x. We can set these equal to one another. 5 equals a plus b. Again, because they both had an x term. And now we're also going to set this equal to this constant term. Negative 3a plus b4 equals negative 1. So I'm going to explain again what we did. We set a plus b equal to 5, the first term, because they had an x. We set this equal to the constant term. Now what does this look like? Systems. Good. What did you say, Logan?
I don't say you got you use the 5x minus 1 and do all that, so that I don't do it.
This part? These both have an x. So what I did was I set a plus b equal to this term, 5. Ignored the x's. And then I set this, 3a plus 4b equal to negative 1.
Why isn't it a plus b equals 5 minus 1? I don't understand.
Because these both had an x, so I could just set these equal to one another, the 5, a plus b and the 5. These did not have an x, just like this one didn't have an x, so that's why I set these equal. Alright, Kelsey said didn't you say it looked like systems?
Yes.
And that's correct. Because we got two variables, and we need to solve for two variables. So let me write them both in standard form. A plus b equals 5. I'm not changing it, just writing it in a different form. And negative 3a plus 4b equals negative 1. Again, I just wrote these in standard form, so they'll be easy to see that it's a system. And so we can easily see how we need to solve it. Alright, y'all want to do elimination or substitution? Elimination is a good choice. What do we need to multiply this by to cancel out the a's? Yes, or we could multiply this by negative 4, right? Which one do y'all want to do? Alright, so this multiplied by 3 would be what?
3a plus 3b.
Very good. Do I have to change this?
Nope.
Now we're going to do what? Equals? So our b is what? Alright, how do we find our a? Okay, so this one would be pretty easy to do, correct? So we'd have a plus 2, because that's what we just solved b for, equals 5. And now how do we solve for a? So a is? Very good. So now we can write our final answer. The rational function we started with, this 5x minus 1 over x squared plus x minus 12, can be broken into these two fractions. Instead of a on top, we can write what? 3 over x plus 4 plus
2
over. Very good. That is this rational function broken into two different rational functions.
So that's our answer.
Yes. It's called partial fraction decomposition. We decomposed this one to two different fractions. Simpler fractions. Questions about that part?
This is going to be on the test.
Why would you want to do this? I'm just kind of wondering.
You'll have to use it in calculus when you're doing integrals.
I don't like it. Like I've never had it before.
For like if you go into any major, most of y'all have to take calculus, like basically any major. You have to take calculus. Say that again. Alright, this next one they've already factored for us, so we can save that step. And also we don't have to go through this process if y'all remember what I told you, okay? If not, we'll go through the process. So let's write this. X plus 14 over x minus 4, x plus 2. I just rewrote the problem. And this is going to be equal to a over what? Plus b over x plus 2. We're going to break it into two different fractions just like this. We just need to find a and b. All right. Right. Yes, go ahead. I'm sorry.
I'm probably about to get ahead of you, but you said, so we set the top to the left side, and then we put a first coefficient in the denominator, and then b the other one.
Mm-hmm.
Then we add them. I mean,
Say that one more time.
so we do a times 6 minus 4 plus b times x minus 2. Then we set it equal to the top.
Almost. I'm going to hear you cross multiply. You said 6 something plus 2, I think. It's going to be a times this, b times this.
Okay.
Is that what you're asking?
Yes, ma'am.
Okay. So if you remember, you can just cross this part out, put x plus 14 because we're going to be multiplying by this denominator equals a times what? Plus b times, yes. Alright, now we're going to multiply this part out just like last time. So we get x plus 14 equals what?
Oh.
8x plus 2y.
Good. Plus,
Bx. 11b+.
let's put 4 first.
Oh, my. What did you say?
Alright, we're going to leave this side the same. This side we're going to group the x terms together. So we'll put an x on the outside, and if I take an x from both of these, I'll have what on the inside? A plus b. Good. These terms don't have anything in common, but I'm going to group them together because we got to set this equal to our constant term. Alright, I'm going to scoot it over some, so does everybody have this part down?
So would that be 1 equals a plus 2?
Yeah, let's write them in standard form though. So let's write this part first. It's going to be a plus b equals the coefficient of x on this side, which is what? 1. Good. And it's going to be 2a minus 4b equals the coefficient here, 14.
And you can just multiply -2 by the first place.
So you want to cancel out a? Okay. So cancel out a by multiplying it by -2 because we want these to be the same. So this will be what?
-2a minus 2b
Equals?
-2.
Good. So the a's are going to cross out. What's going to give us here? Equals? So b is? Very good. And if you can do it in your head, plug in -2 here. What would you have to add the -2 to get 1? 3. Alright, so we've solved for our A, we've solved for our B. Tell me how to write the final answer. X.
Minus 4.
Good. Because the A has to go over the X minus 4 term.
B over x plus 2.
And would it be minus B or plus B? Minus, because it's what? -2 over X plus 2. That's it. It's not hard, it's just a lengthy process.
So when you, at the beginning, when you cross multiply, whenever you get your answers, you don't do it over the ones you crossed over, you do it over.
Correct. So whatever A is, that's what you have to put first.
Okay.
This is easy.
Questions? Alright, yes, go ahead.
If the second variable, if b is negative, can you change to negative?
Yes.
Or minus?
Alright, flip it. I just want you to do C on your own right now. Just C. Can you what?
I guess it's going to be this one. Yeah.
This one's actually not as easy as it looks. Yes, you got to factor first. And I don't mind if y'all talk to each other for help. I just get aggravated when y'all talk to each other about other things and y'all not talking to each other.
Thank you.
Can you raise your hand?
I'm not sure.
They're working on that one now.
Oh, yeah, I remember this.
Yeah. Which one is vanilla? It's probably the only one that has this. Good job. Yes.
I'm confused why it's factored.
This one's part A. How the bottom's not factored. So we have to factor it. So the other factors are -3, then add to be 2. So we're good, except the 1 is the one that has to be negative because what's the minus 1? Yes, we need to factor 2. This other way around would be -2. Right? And that's where we'll start. Not too much to fix. Great job. Alright, we're going to start going over this one. If you're not done, it's fine. What did y'all end up factoring this into?
X plus 3x.
Is this the correct factoring part for this bottom? Yes? Okay. So now I'm going to set it up as a over x plus 3 and b over x minus 1. Alright, tell me what I would write from here if I multiplied everything by this bottom.
I put 5x plus 7
Equals
a times x
plus,
b a plus 12.
good. Everybody got that far?
Does X plus 3 have to be under A?
Yes. So you Well, no. This can be different if you factored in x minus 1, x plus 3. So, yes, that's fine. Alright, so this would be 5x plus 7 equals what?
AX minus
Plus bx plus 3b. Good.
A. Now flip on.
Hold on. Any questions about that part? Alright, so now we leave this the same. We could group what together?
A plus B.
And
3B minus A.
good. Let's write it as negative a plus 3b. We want it in standard form, so we want that a to be first. Alright, what do I set a plus b equal to? Good. And what do I set negative a plus 3b equal to? Very good. Do I have to change anything here if I'm going to do elimination?
No.
Why?
Because A and A is already constant.
So when I add them together, I'll get 4b equals. So b equals. And then when I plug a back in, what'd y'all get? Now some of y'all might have gotten a equals 3, b equals 2. Why does it not matter the order on this one?
When you add them back together, it's not
Yeah. So this is 2 over x plus 3 plus 3 over x minus 1.
So putting your answer should be 2 over x minus 1 plus 2 over x.
Yep. Questions? Alright. Next one. Has anybody started on the next one?
A little bit, yeah.
So it's kind of different.
It is different.
Yeah, you should. You'll get fractions on this one. So we're going to go over this one together, and then we'll call it a day and finish the rest of them Monday, okay? Because people still have to finish their checkpoint. Alright, so this one I'll set it up first as a over x minus 4 plus b over x plus 3. Alright, what do I write from here? Yes. Alright, Darren, what would I do from here?
Distribute
Okay, so tell me what I get if I distribute the A.
ax plus 3a plus bx minus 4b.
Very good. Alright, Colby, what could I group together on this side? Very good. And then the other two terms would be good. Alright, so I'll set a plus b equal to what? And the other two terms, 3a minus 4b, equal to what? Yes. Alright, and now we can do elimination. Do y'all want to cancel out the a or the b? Okay, so I'd have to multiply this by what? Good. So Kelsey, that'll give me what?
I got negative 70. Negative 3a minus 3b equals negative 21.
Good. So Miles, when I add these together, I'll get what right here? Good. Negative 7b equals? Good. Alright, on these, it's called partial fraction decomposition. Okay, so we have to have our answer as a fraction, so do not turn this to a decimal. If I divide by negative 7, b would be what? Yes. We do, but it's going to be real easy right here.
Oh, because it's 7.
So we got a plus 25 over 7. I'm plugging it back in here, by the way. And let's write 7 as a fraction.
7 over 1.
Yeah, but let me do this up here. 7 over 1, but I want it to have a denominator of what?
So you would flip to 1 over 7.
I want this to have a denominator of 7. So I have to multiply the top by,
49 over 7.
yes, 7 as well. Because 49 over 7 is 7. Now we're going to subtract what? Good. So what's 49 minus 25? Good. 24 over 7. So how you'll write your answer is you'll leave 25 on top just like you see it. You'll leave 7 on the bottom just like you see it. So here's what I mean. It's going to be 24 over 7 for A. You lost on how to find A? Okay, so you understand we got this part, right? So we plugged in B right here, A, and then we changed 7 to 49 over 7 so they could have a common denominator. So then we move it over by subtracting. So 49 minus 25? 24. You good now?
Yes,
Okay. So you will just bring the binomial x minus 4 and leave it with 7 on the bottom. It's bothering me that this is not in the middle, so I'm going to write that in the middle. And then it'd be plus what on top? Over 7 times x plus 3. So you can have fractions. Just remember to put the numerator in the numerator, denominator in the denominator. Did y'all notice a pattern on A, B, and C? Not just that. What is this added together going to be? 5. Isn't that the first term here? Flip it over to B and A. What's 3 minus 2? Isn't that right here? And then 3 plus 2? 5. Just showing you some patterns. Alright. If you did not finish your checkpoint, that's what you're working on. If you did, please do not talk to other people and help them. Please just sit quietly
And enjoy the rest of class.